Hi class, today we're going to talk about function machines. Before we talk about stacking function machines, we are just going to review how to evaluate functions, what is an input and what is an output. Another way to write a function is with the notation f of x instead of y. The function named f has output f of x, and the input is x. So if we take a look on the right side here, we have an example. Our value x equals 5 here, this is the input. The input is just the value that you are substituting into your function. Our function is f of x equals x minus 2 squared. F of x is really the same thing as saying y. So when we see f of x, keep in mind it means the same thing as y, and we read that as f of x, not f times x. I know the parentheses look like multiplication in this case, but it is not. We read this as f of x. Just like here, we would read this as f of 5. So since our input is 5, that just means we are substituting everywhere where we see x, we're going to replace that with a 5. So I'm going to write it as f of 5 is equal to parentheses 5 minus 2 squared. And when you are going through this, we do want to show our work here following order of operations. So first I'm going to work out what I can in my parentheses. 5 minus 2 is 3, and then we have 3 squared, which is 9. So that means f of 5 equals 9, where 9 is our output. It is what we get out of our machine at the end. So what we have here below is we're just going to practice when given an input, how to evaluate that function given the input to get a new output. So over here, we have m of x is equal to x over 4 plus 2, where the input is 12. So if the input is 12, I'm going to write m of 12 is equal to 12 over 4 plus 2. And then following our order of operations, we're going to work out this division first. 12 over 4 is 3. 3 plus 2 is 5. So m of 12 is equal to 5. Our output is 5. Let's look at p of x. So for p of x, we are saying our input is 5. So everywhere where we have x, we are going to write 5 instead. 2x is the same as 2 times x, so we have 2 times 5 minus 1. Following order of operations, I want to simplify everything inside my radical first. So I'm going to work out this 2 times 5 first, that's 10 minus 1. I have square root of 9, and the square root of 9 is equal to 3. So in this case, our output is 3. And let's look at one more. Q of x is equal to 3 to the x plus 4, where the input is 1. So that means I'm going to write q of 1 equals 3 to the first power plus 4. 3 to the first power is still 3. And 3 plus 4 is 7. So that means q of 1 is 7. With an input of 1, we have an output of 7 for this function. So now that you've had some review on functions, their inputs and outputs, you are going to work with your team to put together 4 functions. You're going to be given 4 functions, f of x, g of x, h of x, k of x, and you're going to need to put them in the correct order to get a specific output when given a specific input. use the space for scratch work, then record the final process in the back. So before you go and do that with your group, we're going to just go through an example just to clarify what we mean by giving a specific input to get a specific output, and what you might need to go through in order to stack the functions the correct way. What order do we need to stack the functions f of x and g of x so that when 2 is dropped in the first machine and both machines have had their effect, the last machine's output is -1? So first, I'm going to recognize what my functions are. In this case, f of x is equal to x minus 1 squared, and g of x is equal to 4x minus 5. When 2 is dropped in the first machine, so what that means, so when 2 is dropped in the first machine, that is saying that my original input is 2. And both machines have had their effect. The last machine's output is -1. And my final output is -1. So what I want to do here is I'm going to substitute x into one of my functions, and then I'm going to get an output, and I'm going to plug that output into the other function. And I don't know if I'm going to get it right the first time, but the goal here is to keep trying and persevere. So I'm going to go ahead and try plugging that input into g of x first. So then that would be g of 2 is equal to 4 times 2 minus 5. And then I'm just following order of operations. So this is 8 minus 5, and that is going to give me a 3. So if I'm stacking machines, I now have a new value here of 3 that I'm going to plug into the remaining function. So I'm going to now go to f of x and do f of 3. I'm going to evaluate the function f at a value of 3, so that I have f of 3 is equal to 3 minus 1 squared. That's 2 squared, which is 4. So my final output here is 4. The goal, though, was to get -1. I didn't get -1, so this order doesn't work. So maybe I need to switch the order. So now, what if I start with f of x first? So remember, my original input has to be 2. So I'm going to plug in 2 first into f of x. So that's quantity 2 minus 1 squared, 1 squared, which is 1. So now that I have this output, it's going to be the new input for the remaining function g of x. So now I'm going to do g of 1 using this function here. 4 times 1 minus 5, 4 minus 5, which is -1. So was this the output that I wanted? Yes. So that means, to answer my question, because remember, yes, this is a work that supports what you're getting, but we need to remember, well, what is the question we're trying to answer? So I always like to go back and read my question again, just to make sure that I've actually answered it. What order do we need to stack the functions f of x and g of x? So when 2 is dropped into the first machine and both machines have had their effect, the last machine's output is -1. So the question we're trying to answer is, what order? So what was the order that worked? So if I look here where I was able to put in the input of 2 and get an output of -1, I did f of x first and then g of x second.